Hey Ramblers, this video covers chapter 11.1, which introduces us to the concept of area. Probably a topic that you're already familiar with, but we really want to look at the concept of area again, make sure you're comfortable with the properties of area, and after watching this video you should be able to find the area of a rectangular or square. Okay, let's start with the concept of area. Now area is defined as the amount of square units that can fit inside a closed region. Now, that works really well when you're talking about a rectangular region or even a square region. It's easy to fit those square units inside of a square or a rectangular region. But when the region gets to be triangular, it gets a little bit tougher. When it's circular, it gets to be tougher still. In fact, finding the area of a circle is one of the great problems in geometry in antiquity. But when we start to look at amorphous shapes, like the shape of a country or the shape of a lake, or something on the earth in geography, looking for square units inside those shapes gets much more difficult, to the point where we need other tools like calculus. But geometry is going to help us to find formulas for some of the standard shapes, and that's where we'll get started. So let's take a look at finding the area of a rectangle, and we'll extend that to a special formula which applies to squares, and then we'll move on to parallelograms and triangles in the next video. Okay, Ramblers, take careful notes, just a couple definitions, and I know you're already familiar with it, but nevertheless, pay close attention, pause often, and thanks for watching. Okay, understanding area is probably going to be something that's pretty familiar to you, but nevertheless, let's take another look at that definition. The area of a closed region is just the number of square units of space that can fit within the boundary of the region. Well, that's not too hard. That makes a lot of sense. So when we look at a rectangular region, all we're doing, finding the area, is figuring out how many of these square units fit inside it. Okay, well, what are some of the properties of area? Well, area has the property that every closed region has an area. And if two closed regions are congruent, like two congruent triangles or two congruent squares, then their areas are congruent. The last property is a little longer, so I made you an example to kind of emphasize it. It says if two closed regions intersect only along a common boundary, then the area of their union is equal to the sum of their individual areas. What? Let's take a look. Okay, so we have a screwy figure. It kind of looks like a trapezoid attached to the roof of a house. But what this last property tells us is that if we wanted to figure out the area of the entire figure A, B, C, D, E, F, G, we would simply add the area of the pentagon to the area of the quadrilateral. So the area of their union would be equal to the sum of their individual areas. Okay, so let's go back then to the rectangular region here. If all we're doing to find area is counting up the squares, there's of course two ways to do it. You could do it like you did in first grade and just count all the squares. And when you did, you'd see that there were 1, 2, 3, 4, 5, 6, 7, 8, on and on until you came to 24. And you could say that the area was 24 square units. Or you could multiply. You could say that there are 6 squares along the base. Each base has 4 rows or 4 squares above it. So 6 times 4 is 24. That, of course, is going to be our first formula, that the area of a rectangle is going to be equal to the base times the height. Now, a square is a very special rectangle in which both the base and the height are the same. So we have a special formula for the area of a square, which is just area equals side squared. Now I know this probably seems really self-evident and maybe a little bit of waste your time, but I thoroughly suggest you put some space in your notebook or somewhere that you have easy access to it. Maybe make a flashcard. Your success in this chapter and the next one is going to be dependent on how familiar you are with these formulas. We're going to get a lot of formulas. And what's more is we're going to get many formulas for the same figures. So please, keep them organized, keep them all together in one place so that you can drill yourself before quizzes and tests. Okay, there's a couple of tutorials I want to look at in this section, so I'll attach them to this video, and thanks for watching. Okay, number 16 on page 515, they ask us to find the area of the rectangle formed by drawing two diagonals of a hexagon. Now we know that each side of the hexagon is 12. We're given that. So we have to find the length of these diagonals so that we can use our formula for the area of a rectangle. Well, what I'm going to do is draw a altitude to one of the sides and one of the isosceles triangle, and it will form a triangle, the hypotenuse of 12 and an altitude. Now I remember from chapter 7 that the formula for each angle of a hexagon is 180 times 180 times 6 minus 2 over 6, which is going to equal 120. So each of these angles is 120. Now if they tell me that that's a 90-degree angle because it's a rectangle, that means that this remaining angle here is only 30 degrees. So I don't just have a right triangle that I've created by drawing my altitude. I have a 30, 60, 90. So the side opposite 30 is going to be half of 12, or 6, and the other leg is going to be 6 root 3. Now, I recognize that since this is an isosceles triangle, 6 root 3 will be half of the length of that diagonal. So my rectangle is going to equal 12 times 12 root 3, which is 144 root 3.